Hello everyone. Welcome to a quick presentation about coordinate systems and their projections. So, what are coordinate systems and why are they important in GIS? Well, one important question this presentation explored, that is how you would describe your location to someone. The intention was to develop a general understanding of the coordinate system, and this presentation will explore a few options used in ArcGIS. So let's start the presentation. The coordinate system provides a form of reference for your data or location on the surface of the earth. It aligns your location relative to other locations, and it helps create maps accordingly. Well, there are thousands of coordinate systems available. The most two are outlined here. So the number one, spherical or geographical coordinate system. Number two, plane or projected coordinate systems. A geographical coordinate system is measured in angular units, while a projected coordinate system is measured in linear units. Local coordinate systems are often used for large scale, like small area mapping, where the distances are calculated using the local coordinate system rather than global coordinates. Our Earth is 3D. It has undulations, ups and downs, and our map will be a flat surface. A projection is a method by which we can display a 3D surface on a 2D flat surface. These flat surfaces can take on the forms of a computer or screens. However, there is always going to be some sort of distortion involved in the ArcGIS Pro utility. We can change the projections of the map as well as the individual layers that we have within our analysis. ArcGIS distinguishes geographic coordinate systems and projected coordinate systems in their interface. A GCS or geographic coordinate system defines where the data is located on the Earth's surface. A PCS or a projected coordinate system tells us how to draw the data on a flat surface, like on a paper map or a computer screen. A geographic coordinate system or GCS describes a location in a spherical measure of latitudes and longitudes. GCS typically is in decimal degrees and describes longitudes towards X direction and latitudes towards Y direction. Longitudes measures angle in an east-west direction. Each line of longitudes run north-south and measures the degree east or west of the prime meridian. Here the prime meridian is an imaginary line running from the North Pole to the South Pole through Greenwich, England. This angle is considered 0-degree longitudes. West of the prime meridian is recorded as negative longitudes and east of the prime meridian is positive. On the other hand, the equator is at an angle of 0-degree latitudes. The northern hemisphere has positive measures of latitudes and the southern hemisphere has the negative measures of latitudes. Accordingly, positive X and Y values indicate a location in the north of the equator and east of the prime meridian. Similarly, negative XY values indicate south of the equator and west of the prime meridian. Now, I will describe a little bit about the projected coordinate systems or plane coordinate system, which is in XY coordinates. The spatial data can also be expressed using projected coordinate systems or PCS. Linear measurements are used for the coordinates rather than angular degrees. Actually, a GCS defines a PCS through a map projection and the projections parameter. In this slide, I will outline UTM, Universal Transverse Mercator System, one of the popular plane coordinate systems. The UTM consists of 60 zones. The zones are numbered 1 to 60, beginning at 180-degree longitudes and increasing to the east. Each zone encompasses 6 degrees of longitudes. Each of the 60 UTM zones is 1 million meters across, and they do overlap slightly. As concluding remarks, I would say, one system is not more or less accurate than the other, just two different ways of positioning a point. Changing coordinate system is needed for a commonly used coordinate system in an analysis. Mathematical calculations can convert the coordinate system, and there is no perfect way to transpose a curved surface to a flat surface without some distortion. There are more than 4,000 coordinate systems in the ArcGIS platform. So you should be able to find one that matches your dataset. You can also create a custom coordinate system to display your data. Let's go to the ArcGIS Pro interface to quickly explore how you can check the projection systems of an individual layer or for the map. Here you can see ArcGIS Pro interface. Under the contents you can see a lot of layers. You can select one layer. For example, after right clicking this one, you can go to the property. The property dialog box will come. So out of the option you can select the source, then a little scroll down to select the spatial reference, where you can see the coordinate system and the projection system. Geographic coordinate system and WGS 1984, that is the projection system for that particular layer. So this is how you can check the coordinate system and the projection system of any individual layer. You can also go to the map. After right clicking you can select the property, where you can find the coordinate system as a direct option. So it will primarily show you the three options: layers, geographic coordinate system and projected coordinate system. The layer will contain all the layers that have been used in your project along with the projection system. So for example, after clicking WGS you can find a lot of layers and enlisted. All these layers are used in this project and have the same coordinate system, same projection system, that is WGS 1984, which is a geographic coordinate system. For example, if you click the geographic coordinate system, you can find WGS enlisted here. So I already particularly talked about UTM, which was a projected coordinate system, and you can find UTM enlisted here in the projected coordinate system. So you should be able to find a suitable projection system for your project, so you can decide based on your data set characteristics here of your data and your project goal. So I will make a separate presentation explaining how you can convert one projection system to another projection system, the related mathematical calculation and geometric process. So thank you so much for listening.